This video presents the electric vehicle, EV, and electric vehicle supply equipment, EVSE test environment that is currently embedded into the AIT Smart Test Laboratory. This environment has been developed in order to provide a framework for electric grid compliance and interoperability testing. This environment constitutes of three interconnected parts. The first part is the hardware environment, which is the electric grid, the EVSE, and the EV. Each of these components can be implemented either as real hardware or as a fully controllable emulator. The second part is the simulation system. This utilizes the LabLink message bus. This was also developed at AIT. Different simulators, for example grid simulation or large field simulations, can be connected to the test environment. The third part is the control system, which creates the link between the simulation and the hardware entities. The control system is remotely accessible and was developed using open source components. Now let's watch the environment in action and look at the main steps carried out during the test case. The first step is to connect the EVSE to the laboratory infrastructure. Now the power supply to the EVSE can be activated. It's clear that the charging cable must be plugged both into the EV and the charging station. Having done the preparation, the test case execution can begin. The utilized measurement equipment allows a full transient three-phase measurement of voltages and currents. It is also configured so that the actual values for voltage, current, active and reactive power are displayed. Here you can see the initialization of a charging process. The test case executed in this video is an IEC 61851 compliance test. Specifically, the charging current limitation will be evaluated. In this video, we also use a time-lapse. The charging current is decreased stepwise by 1 amp every 30 seconds. Now we can analyze the measured data. Currently, the data analysis is not automated. However, this functionality can be easily implemented for future tests. In this test, the maximum values of the charging current were within bounds and the timing constraints were fulfilled. The example test case is passed. The presented setup offers a unique hardware-in-the-loop environment for testing IEC 61851, IEC 15118, and OCPP. The EV and EVSE can be connected to a low-voltage grid simulation, and the charging characteristics can also be analyzed. Overall, the AIT EV/EVSE test laboratory presents the perfect framework to evaluate the interactions between EV/EVSE, the electric power system, and the ICT environment of the smart grid. This work was partly conducted within the European project Portavoz.